speakers are Shane DeWees and Stephanie Ma. They're both students in Carla D'Antonio's lab. And, I think we've seen from these first talks how complicated this can all be. And they're going to talk about some of the things we have on our side, things like getting more hardy plants established first and using a lot of volunteer help. So Shane's video popped up here. His dissertation work and broad research interests are focusing on understanding the drivers of vegetation fluxes, how to apply ecological theory to inform restoration ecology, and post-fire effects on tree and shrub physiology. He's passionate about preserving California's amazing floral biodiversity and hopes that his research can play a small role to that end. Stephanie Ma is also in Carla's lab. She studies shrubland restoration and the impacts of drought on chaparral recovery following fire. She's a plant community ecologist with a focus on Southern California chaparral and earned her BS from UC Davis and master's from UC Santa Barbara. She's interested in applying her skills to the protection and restoration of local plant communities and engaging with the Santa Barbara community, including potential future ecologists. So I'm going to turn it over to you two. Thanks so much for being here today.
Great. Thanks for having us here. We're excited to share some of our work with you all today. And yeah, Carla and Nicole set up really nicely the need for chaparral restoration and where it might occur. And so Stephanie and I will share our experience with what that work actually looks like and how we can hope to make it more successful going forward. And so before we dive into that, though, we wanted your help solving a commonly discussed field debate of which is the better snack, goldfish or Cheez-Its. Feel free to throw that in the chat and we'll circle back to it in a little bit. But so the work that we'll be talking about today occurs just outside of Piru, California, where Carla showed some pictures of already and discussed the need for restoration out there. And as you can see, it's almost directly inland from the Botanical Gardens in the western edge of the Los Padres in Ventura County. And as you can see in the background, it's comprised of a very heterogeneous landscape of a wide range of elevations, aspects, and vegetation types ranging from trees, sage scrub, chaparral, and non-native grasses. And as Carla showed earlier, previous research that I've done in the area has showed that from 1930 to 2009, there's been widespread conversion of chaparral to non-native grasses, highlighting the need for restoration in this area. And we really see our work as a case study in chaparral restoration, with the areas that we're working in highlighting some of the hardest areas within this landscape to restore. Close to road, lower elevation, these southwest facing slopes that are going to be the most sun exposed and hot. And therefore are going to need the largest active human hand to restore and are not likely to passively restore over time.
So we will start by sharing some of the lessons learned from our field research, so kind of focused on the ecological framework that we've built and then also the social framework. And so thinking about the ecological framework, we found that transplanting seedlings was really successful, and then also focusing on the individual species that we're planting, controlling for weeds, specifically those non-native annual grasses, and then also considering the planting location, so pre-existing locations and then creating new locations, and then restoring in phases. And then for our social framework, we found that, we worked a lot with UCSB students, and so meeting these students kind of where they were was really important, as well as creating an interconnected community, and then just the reminder to be joyful when working with these students. And so my research questions focused on kind of asking those initial questions of, how do you do restoration, chaparral restoration? And so focusing kind of on these bottlenecks or constraints, I focused on two main questions of kind of, how did these species get there? So the desirable species, are they present already in the soil seed bank, or are we going to need to bring plant material in? And then thinking about competition, again, with those annual non-native grasses, and then also with native species. And then through all of our fieldwork, we learned something about logistics in terms of personnel and time. And so Shane and I are both happy to talk more in detail about all of our research. I'll kind of give you an overview of my research right now. And so kind of looking at the first question of how do species get there, we looked at are species already present in the seed bank, and we found that no, there were no desirable shrub species that were present. And so we would need to bring in species. And then next we looked at, well, if we're going to bring in species, do we have greater establishment by seed or by seedling? And these are the 5 species that we focused on. So white sage, chaparral bush mallow, felt leaf yerba sante, chaparral yucca, and purple sage. And we found that we had greater establishment when we planted seedlings. And so kind of moving forward, transplanting seedlings worked for us. And then next, looking at competition. So again, looking at the competition with the annual non-native grasses. So if we remove that competition from those weeds, do we have greater survival, or how does survival change with the removal of these weeds? And we did find that we had greater survival with greater weed removal. So it really is important to control the weeds at the site. And then we looked also at the competition, or if there are benefits of planting seedlings kind of underneath mature shrubs. So maybe there is some competition for light and water, but maybe there's benefits if they're planted kind of in the shade under those mature shrubs. And we found that seedling survival was really dependent on the species. And so, thinking about the functional traits of it, it's really important to think about kind of the species and the growing conditions for that species. And then next, thinking about logistics, this is an image of our site. And so we would park kind of lower down on the road, and then we would hike up to my site kind of midway up the hill. However, Shane's sites were all the way up at the top of the field. And so when we say that working with undergraduates allowed us to do a lot of this research, it's not a figure of speech. It's quite literal that they were really integral to our research. So they helped us clear sites, they carried equipment and plants, they helped us transplant water, weed, and also collect data. And so through working with these UCSB students, we started to build a social framework of how to engage and inspire students. And so the first thing that we really found was useful was to kind of meet these students where they were. And so this could be physically of, where are they, getting their emails. And so posting to the UCSB listservs was really great at connecting with the students. And we worked a lot with Eric Zimmerman and Mike Tucker, who are the undergraduate advisors that send out the listservs. We also kind of met these students where they were in terms of experience. So for us, we didn't require any previous experience in the field. And so if students were just interested in trying it out, see if they liked fieldwork, they were welcome to join us. And then also scheduling. So we went out to the field on Saturdays just because that was the most flexible day for everyone's schedule. And then next, kind of, we created an interconnected community. So we wanted to create as many win-win situations as possible. So not only the students gaining field experience and then us, accomplishing a lot of field work that day, but then also thinking about flexibility for the students with their schedule and for us being able to have a full crew. And so we found that these shared sign-up sheets were really useful, where people could pick the week that worked for them, and then also we would know that we would have a full schedule. And then also learning together, so creating a supportive culture where we could ask questions and learn together. And then also networking, so sharing resources and job postings that we knew about with the students, and then also providing letters of recommendation or providing a job reference to, again, help those students that really found an interest in restoration to entering the career field. And then lastly, this reminder to be joyful. And so snacks were really an important part of the keeping morale high. So this also brings it back to the question of goldfish or Cheez-Its. So not only is it a snack that a salty snack, but it also can provide fodder for a great game, which is debating the benefits of one versus the other. Another game that we found that was really fun to play in the field was 20 questions. And then finally, photos. So in the field, we took a lot of photos of action photos of the students kind of participating in fieldwork. And then we always took a group photo at the end of the day. And then in the email afterwards, we'd share appreciation and thanks that they helped us with this work, but then also sent these photos out in the emails to hopefully remind them of all of the fun that they had that day. And so kind of with what we learned through the kind of asking those fundamental initial questions, and then also with working with students, this really led to this next phase of restoration, or restoration research, kind of led by Shane, which focused on the different species in chaparral restoration.
Yeah, and so once we built that community engagement and Stephanie answered some of those super foundational and really important questions about chaparral restoration, we wanted to scale up with our research and go from the plot level, where you might have more homogeneous sites, to the landscape level, where you're going to have a much more heterogeneous landscape and where larger restoration projects are really going to occur. And with that, we had a goal of creating an ecological framework kind of centered around three main questions that would allow us to understand the ecology behind what we see with our restoration success and develop better methods to lead to higher success in the long term over time. And so the framework that we're trying to develop is really centered on these three questions of: where in a landscape can species survive? Can some species help others survive better? And then can we extend where in a landscape we can get our species of interest to survive? And so today, I'm mainly going to talk about our research focused on this first question, as the second and third are still ongoing projects, but I will discuss them briefly in the end. But focusing on just looking first at where out in the landscape different species can survive. We planted over about 6 acres with 10 different species for a total of just over 1,600 individuals. And this picture can start to give you a scale of what that looked like. If maybe you can see all of these little flags across the landscape, and those are all individual planting locations where we put a plant. And this is representing maybe only about a third of our site. And so you can see how this got very large very quickly. And that's where that community engagement was really essential. We had undergraduates helping us with clearing out each individual planting location, getting the plant material up there, putting all the plants in the ground. And then, as Carla alluded to, the last couple of years of work out here has been incredibly dry. And so we've had to help water them during the growing season to help our plants establish and keep them alive, to give them a chance going into this summer. And so as far as what we found, this graph here shows the number of plants alive on the y-axis over time on the x-axis, with all of our plants, about 1,600 when we finished planting around March of 2020. And then the real takeaway of this is, while we saw some mortality going into the end of the growing season, largely due to gopher activity and some transplant shock, by far the largest degree of mortality that we saw was during that first summer, from going from the end of the growing season in May to when we theoretically should have first rains in November. To add to the challenges that we saw, this was an abnormal year where we didn't get our first rains until closer to January. And so we did see some further mortality here. But after that second winter, after planting, those first rains, we see a dramatically flattened out slope of less plants dying. And so this really highlights that first summer drought and the water stress associated with it is the largest barrier to restoration in our area. And as far as species-specific responses, we planted 4 different sage shrub species, 2 true sages, California brittle brush, and chaparral yucca. And we can see that while all 4 species show some decline during that first summer and then flatten out, we have fairly high survival, ranging from about 25% to 50%. And when you look at these species, like Carla showed in her presentation, we see that these species have a variety of drought adaptations that help them survive better. And so this can be having almost succulent-like leaves, the yucca down here, to high reflectance, to these little crenulations, to being drought deciduous, that allows them to drop their leaves during the worst parts of the summer drought, and then with first rains, leaf back out. And so all 4 of these species survive fairly well on the landscape. Whereas our true shrubs, our chaparral shrubs, we see, for the most part, much steeper declines during that first summer drought, and then a range of survival ranging from about 0%, with almost all of our individuals being dead for ceanothus and toyon, to about 5 to 25% for some of our other species. And again, looking at these species, for the species that did better, like elderberry, sugarbush, chemise, and laurel sumac, we think this is really a combination of two things. First, all four of these species have the potential for stored carbon. This is maybe best seen on the left with our elderberry and our roost, our sugarbush. You can see they have these really thick, juicy root materials right below ground, or they're starting to form what we call lignotubers, which are these organs for specialized carbon storage. And it can allow them to kind of shut their leaves down during the worst of the summer, minimize evaporation and transpiration, and then start kind of survive off of the stored carbon. And then additionally, the chemise has extremely small leaves, minimizing the amount of evapotranspiration that might occur in the summer, whereas our laurel sumac and sugarbush have these folded, almost taco-like leaves that allow them to, again, minimize the amount of leaf exposed to evapotranspiration at a given time. Whereas our ceanothus and toyon, they got hit a lot harder during that summer drought and have the lowest survival are these larger, bright green leaves that really have no protection from the sun and are just fully exposed. And that might help them photosynthesize more and grow more in the growing season, but might be more detrimental to them when they're seedlings during that first summer drought. And so going back to our ecological framework that we're trying to create, we do see that there are species differences across the landscape and where different species can survive. And so going to our second question, it kind of logically makes sense of if our sage scrub species survive better and can establish more across the landscape, can we use those to help our more challenging species survive at higher rates? And ongoing work that we're doing is looking at just that. And so here we can see a black sage that we planted a year later. And not only is it beautiful and large and seeding and flowering, all great things that we strive for at the restoration, but you can also see that it has this fairly large shadowed area around it that might be a more favorable microsite to plant some of those harder to establish species. And so ongoing research is looking at planting plots of chaparral and sage scrub communities together, and then chaparral plots in isolation. And we're hoping to track survival and see, and then also measure things like soil moisture, temperature, humidity, sun exposure, and see if as those sage scrub species establish, do they create more favorable conditions that then allow our more challenging chaparral species to establish at higher rates. And then lastly, kind of that last part of the framework that we're trying to develop is looking at, can we extend where on a landscape species survive with different growing conditions prior to outplanting? So does how we grow them in the greenhouse prior to outplanting better prepare them for the field? And so we can kind of imagine that the goal of creating this framework and then applying it is if we have a restoration area visualized here, outlined in black, at first pass, maybe with our first year of planting, we can establish sage scrub species across most of the site as represented in red here. And then some of our chaparral species with moderate restoration potential, like laurel sumac, chemise, sugarbush, and elderberry at some of the more favorable sites, parts of our restoration site. And then the following year, we might be able to follow up and use those pre-established plants as facilitators to extend the range of our moderate potential restoration potential plants to farther across the landscape and get some of those low restoration potential plants like ceanothus and toyon on the site. And then if our third part of the framework of seeing how we grow plants in the greenhouse is successful and we can extend the range, we can then extend all three groups of species farther across the landscape. And over time, this framework might allow us to go from a degraded site to a beautiful, diverse, restored shrubland as visualized here. And so with that, we want to leave you with some of the lessons we've learned from our research and both ecologically and socially. And our emails are seen in case you want to follow up with any questions or discuss our research more. Yeah, thank you for your time.
Shane and Stephanie, thank you so much for your talk and your brains on this topic, because it's a challenging situation. We have to get creative, and I'm glad to see you got so much help with this. We do have a few questions in the Q&A, but I think some of them you can type the answer into because we are at 11:40. We can save some for the panel discussion as well. So good job. Thanks so much.